So we're back with section 4.2. And remember we started the addition rule in our first video. Section 4.2 is about the addition rule when you have an OR. An OR event, what is an OR event? It connects two events together into one big event, basically. So here we have a situation, a card is drawn from a deck of 52 playing cards. Find the probability of getting a heart or a face card. Probability of a heart or a face card. So remember what the addition rule says. The probability of an OR event, you take the probability of first the heart plus the probability of the face card, and then you're going to subtract out the overlap. So you're going to subtract the probability of getting both a heart and a face card at the same time. So what does that mean, a heart and a face card? That means a face card that is a heart. A heart and a face card at the same time. So a heart that is a face card and a face card that is a heart. Okay, so what about hearts, first of all? What's the probability of getting a heart? So how many total hearts do we have? I mean, if you were to look here carefully, the hearts are these guys, right? There are 13 of those. So that's going to be 13 out of 52 will be your probability for a heart. Right, 13 ways to get a heart out of a total of 52 cards. Now, what about a face card? A face card. Let's see. Face cards. These dudes right here, right? 3 types of face cards, right? Jack, Queen, and King. But they're 4 suits, so it's a total of 12. All right, so the probability of getting a face card is going to be 12 out of a total of 52 cards. 12 out of 52. Then minus, okay, we want to find the probability of getting a heart and a face card, so let's count up those cards that are both hearts and face cards at the same time. Let me go right here. It'd be just these 3 right here, right? They're hearts and they're face cards at the same time. So it's 3 out of 52. Right, 3 cards that are hearts and face cards out of a total of 52 cards. Now, anytime you're adding up fractions and you have a common denominator, which you want a common denominator, you write the common denominator and you take the numerators, the top numbers, and just add those and then subtract that 3 as well. So you're going to get what? 13 plus 12. It's 13 plus 12. 13 plus 12 is 25, I think. Yeah, 25 minus 3. What's that? 22 out of 52. That's our probability as a fraction, but we want to write this in terms of its decimal representation. 22 divided by 52 is, it's about approximately, we're going to round, I'm going to take it 3 decimal places. 3 decimal places, 0.423. All right. Okay, so the other way to do that without using the addition rule, you could go without the addition rule. You could just count up those cards that are hearts or face cards. So if I just wanted to count them up, I would go here. I'm going to say, okay, first I'm going to find all those cards that are hearts right here. Right, there are 13 of those. And then to that I'm going to add the additional face cards. So these, and these. Right. And if you count up all those cards together, you should get a total of, let's see, 22. Yeah, 22. That's 22 cards that you could choose from. And out of a total of 52, so yeah. That's what we had right here, right? 22 out of 52. That's the quick way to do it without using the addition rule. Sometimes, though, the addition rule is really handy when you get into some complex problems and it's hard to count things up like that. I probably won't do any like really hard problems in this class. So this is just a basic introduction to probability. Okay, let's do another problem. Problem 3. We did a heart or a face card. How about a diamond or a red? Okay, let's find the probability of a diamond or red. Probability of diamond or red. This is an OR statement, so we're combining diamonds together with reds into one big set. It'll be the probability of getting a diamond plus the probability of getting a red minus the probability of their overlap. That's the probability of a diamond and a red. If I could spell it, it'd be fantastic. There we go. Well, it's not spelling, it's just writing, basically. If I could write with this thing, I'd be in better shape. Try to squeeze that in. All right. What's the probability of getting a diamond? Okay, diamonds. Be these ones right here, right? There are 13 of those. So the probability of getting a diamond is 13 out of total 52 cards. Let's write that. How about red? What's the probability of getting red? Well, half of your cards are red, right? So it's 26 out of 52. All right, and then we're going to have, what about diamonds and red? So we're going to subtract diamond and red. What cards are diamond and red at the same time? These right here are diamond and red at the same time, right? So remember, diamond and red, that means the overlap. So the overlap between diamond and red is just diamond itself. Yeah, it's kind of interesting. So that's 13 cards there out of 52 total cards. All right, let's put that there. 13 out of 52 is the probability for getting diamond and red. Oh, look at this. This 13 out of 52 and this minus 13 out of 52 cancel. We're just going to have 26 out of 52, which is simply 0.5, right? You could say 50%. 50%. Yeah. So think about what that means, diamond or red. If you want to do this a simple way, diamond or red. So first I would start with the diamonds. And then to the diamonds I would add any red cards I haven't covered. So I would add these cards here. So basically, when you put these two sets together, diamond together with red, you get just red. So really, probability of red is what? 0.5, right? Because half the cards are red, 50% are red. All right. Okay, going back to another problem now. Number 4. Number 4. How about the probability of a 7? Or a 2? If I randomly draw a card, what's the probability of getting a 7 or a 2? So we have to take 7s together with 2s in one big set. If you wanted to use the addition rule, let's try that method. Since it's an OR statement, you have the probability of the first event, 7, plus the probability of the second event, 2, minus the probability of their overlap, 7 and 2. And what's the probability of getting a 7? Well, there are 4 7s, right? Out of 52 cards, so 4 out of 52 is your probability of getting 7. All right, what about the probability of getting a 2? There are 4 2s, so your probability of getting a 2 is 4 out of 52. All right, and then from that we're going to subtract. What's the probability of getting 7 and 2? Well, how many cards are both 7 and 2 at the same time? There are no cards, right? 0 cards are both 7 and 2 at the same time. So there are 0 ways to get a 7 and 2. And that's going to be out of total of 52 cards. So when you combine all this together, you're going to keep the common denominator of 52, and you're going to take 4 plus 4 minus 0. In other words, 8 out of 52. You punch that in your calculator. 4 divided by 52. I'm sorry, 8. 8 divided by 52. That's approximately 0.154. Now, if I didn't really want to go through the formality of the addition rule, you know, the probability of 7 plus probability of 2 minus probability of the overlap, 7 and 2, what we could have done, we just could have gone here and said, okay, we want the 7s. Let me get my marker here, highlighter. I want the 7s along with the 2s, and we're going to combine them in the one set. So you got 4 there and 4 there, so that's a total of 8, right? A total of 8 cards out of 52. So exactly what we had, right? We had exactly 8 out of 52, right? Back here. And then we found the fraction, the decimal. Okay, we'll do one more. How about a 5? Do a problem 5. Right, so this says a 7, no, a black or a red. So we want a black card or a red card. For using our addition rule, we have the probability of black or red. That's equal to the probability of black plus the probability of red minus the probability of the overlap, which is called the intersection, or probability of black and red. So what's the probability of black? And that would be 26 out of 52, right? There are 26 black cards out of 52 cards. Probability of red would also be 26 out of 52. There are 26 red cards out of 52 in total. Minus, okay, what's the probability of black and red? Well, there are 0 cards that are both black and red at the same time. There's no overlap, so 0 out of a total of 52 cards. So you're going to have a common denominator of 52, and you're going to take 26 plus 26 minus 0. It's going to give you 52 out of 52, which is exactly 1. So 1 also means 100%. So you're guaranteed to either get a black card or a red card, right? If you draw a card randomly, you're guaranteed to get a black or a red. So 100% chance there. All right, I think we'll quit with this, and we'll pick up in another video.